What if the reason the mystery of Atlantis won't die has less to do with fantasy and more to do with geology? I've been watching this conversation unfold online for a long time. Every few years, something resurfaces: a sonar scan, a set of stone terraces underwater, a satellite image that looks geometric from just the right angle. The claim follows quickly: proof of a lost advanced civilization erased by catastrophe at the end of the last ice age. The story is familiar. An ancient global society, monument builders, engineers who understood astronomy, perhaps energy. Then, around 12,000 years ago, something happened. A comet, a flood, a rapid shift in climate. The civilization vanished, leaving only fragments misinterpreted by mainstream archaeology. It is a powerful narrative. It has emotional gravity. It also leans heavily on something that is undeniably true. The world did change dramatically at the end of the last ice age. So, before we talk about Atlantis, or underwater monuments, or whether archaeologists are missing something enormous, we need to get the environmental history right. Because that part is not speculative. That part is measurable. Around 26,000 years ago, during the last glacial maximum, global sea levels were roughly 120 meters lower than they are today. Massive ice sheets covered much of North America and Northern Europe. The coastline of every continent looked different. What is now continental shelf was dry land, sometimes vast plains extending hundreds of kilometers outward. As the climate warmed and ice sheets began to melt, sea levels did not rise gently and uniformly. They rose in pulses. Meltwater Pulse 1A, around 14,600 years ago, may have raised global sea levels by as much as 20 meters in just a few centuries. That is geologically abrupt. Entire coastlines would have shifted inland within the span of human memory. If you are a coastal forager or early agricultural community living on what is now submerged continental shelf, your world shrinks gradually, then quickly. Rivers migrate, estuaries expand, saltwater intrudes into freshwater systems. What used to be inland becomes tidal marsh. This is not mythology, it is stratigraphy, it's coral dating, oxygen isotope curves, and submerged paleo shoreline mapping. But here is the part that matters for the Atlantis conversation. Most human populations in the late Pleistocene and early Holocene lived near water. Coastal zones offer predictable protein, fresh water, transport routes, and mild microclimates. The archaeological record we rely on today is heavily biased toward inland sites that survived marine transgression. Entire coastal settlement systems from 15,000 to 8,000 years ago now lie underwater. That gap in our understanding is real, and gaps invite imagination. Consider Doggerland in the North Sea. Today, it is open water between Britain and continental Europe, crisscrossed by shipping lanes and offshore wind farms. During the late Pleistocene and early Holocene, it was a low-lying plain connecting what are now separate landmasses. The Rhine, Thames, and other river systems extended across the exposed shelf, forming braided channels, wetlands, and estuaries. Core samples and seismic reflection surveys have mapped buried river valleys, peat deposits, and lake basins beneath meters of marine sediment. Those peat layers preserve pollen, allowing paleoecologists to reconstruct vegetation. Birch and pine woodland giving way to mixed forests as the climate warmed. Faunal remains pulled up by trawlers include mammoth, woolly rhinoceros, red deer, and aurochs, species associated with shifting post-glacial environments. Alongside them are worked flint tools consistent with Mesolithic technology, shaped by hunter-gatherers who moved through the landscape long before it was seabed. Occasionally, fragments of human bone have surfaced in fishing nets, their radiocarbon dates placing them firmly within this drowned world. There are no architectural foundations detectable in the seismic record, no anomalous metallurgical residues, no geometric urban grids beneath the sediment. What the data show instead is a dynamic landscape gradually inundated as sea levels rose, punctuated by abrupt events such as the Storegga slide tsunami around 8,200 years ago, which would have sent waves across already diminishing lowlands. Doggerland does not reveal a lost industrial society. It reveals how ordinary human communities occupied and then retreated from a plain that no longer exists above water. Or take Atlit-Yam off the coast of Israel, a pre-pottery Neolithic settlement now resting several meters below the Mediterranean. There are houses here, a 5-meter deep stone-lined well, more than 90 burials in situ. The well's upper stratigraphy contains marine shells and debris consistent with saltwater intrusion as sea levels rose during the early Holocene. There is no technological anomaly here. What there is context preserved by submergence. The pattern repeats elsewhere. Pavlo-Patry in Greece preserves a Bronze Age town plan beneath shallow water, including streets and building formations. It is remarkable not because it contradicts archaeology, but because it confirms it. So if submerged settlements are real, and they are, why does the Atlantis narrative persist? Part of this story begins with Plato. In his dialogues Timaeus and Critias, written in the 4th century BCE, Plato describes a powerful island civilization beyond the Pillars of Heracles, usually interpreted as the Strait of Gibraltar. Atlantis, he writes, possessed monumental architecture, concentric rings of land and sea, vast harbors, and a sophisticated political system. It was wealthy, expansionist, technologically capable for its time. And then, in what he calls a single day and night of misfortune, it was destroyed and sank beneath the sea. Plato places Atlantis 9,000 years before his own era, which would situate it around 9,600 BCE, near the end of the last ice age. For many classicists, Atlantis reads as allegory. Plato frequently used fictional societies as vehicles for philosophical argument, particularly about governance and moral decline. In that interpretation, Atlantis is less a historical account and more a cautionary tale about hubris. But outside academic circles, Atlantis took on a life of its own. During the Renaissance, scholars attempted to map it geographically. In the 19th century, writers like Ignatius Donnelly treated it as a literal history, proposing that Atlantis was the source of global civilization, explaining pyramids in Egypt, megaliths in Europe, and complex cultures in the Americas as cultural descendants of a lost mother society. By the early 20th century, Atlantis had migrated from philosophy into esotericism. It became tied to occult traditions, psychic revelations, and elaborate maps placing it in the mid-Atlantic. Later, it appeared in pulp adventure fiction, then in mid-century speculative archaeology, and eventually in modern conspiracy culture. Each era reshaped Atlantis according to its anxieties. In the 1800s, it explained diffusion of culture before global communication was understood. In the 20th century, it absorbed anxieties about nuclear annihilation and lost technological power. In the 21st century, it merges with discussions of the Younger Dryas, impact hypotheses, and rapid climate shifts at the end of the Pleistocene. To bring this point home, all one needs to do is view the imagery of Atlantis from each of these periods. Victorian engravings depicted classical marble cities sinking beneath stormy seas. Art Deco installations imagined radiant crystal towers and advanced energy systems. Modern CGI renderings show futuristic megacities collapsing into tsunami waves. The visual language changes, but the core remains constant, a highly advanced civilization erased by catastrophe, leaving only fragments misunderstood by conventional history. And here's where it becomes interesting. Plato's date for Atlantis, around 9600 BCE, coincides with a period of genuine climatic instability. The Younger Dryas marked a sudden return to glacial conditions after an initial warming phase. Sea levels were rising overall, punctuated by meltwater pulses that reshaped coastlines. Entire continental shelves were gradually inundated. So the setting Plato describes, a world at the edge of dramatic environmental change, overlaps with a real geological transition. That overlap is part of why Atlantis refuses to disappear. It sits at the intersection of myth, climate memory, and the undeniable fact that vast coastal landscapes vanished beneath post-glacial seas. The difficulty is evidentiary. Plato provides no material culture, no pottery styles, no metallurgical signatures, no inscriptions. His account survives only in philosophical dialogue, written millennia after the supposed event. Every later depiction, from Renaissance maps to 19th century diffusionist theories to modern YouTube animations, builds outward from that single textual source. And yet, whenever marine archaeology reveals a submerged structure, whether a Bronze Age harbor in Greece or sandstone terraces off Japan, the Atlantis narrative resurfaces immediately. Because once you accept that the sea has swallowed entire landscapes, the imagination moves quickly from drowned villages to drowned empires. The question isn't whether sea level rise erased coastal settlements. It did. The question is what kind of societies those settlements were. And to answer that, we have to look at the material record, not the illustrations. Here is where historical context matters. The Younger Dryas is real. It is visible in Greenland ice cores as a sharp return to colder conditions around 12,900 years ago, lasting roughly 1,200 years. The mechanisms behind it remain debated. with hypotheses ranging from meltwater disruption of Atlantic circulation to cometary impact scenarios. The so-called Younger Dryas impact hypothesis has generated significant public attention, proposing that a fragmented comet struck or exploded over North America, triggering widespread fires and climatic disruption. The evidence that's been cited includes microspherules, platinum anomalies, and proposed impact markers. Many geologists and archaeologists remain unconvinced, arguing that the data are inconsistent or explainable by terrestrial processes. This is not a fringe debate. It is an active scientific discussion about proxies, dating methods, and sediment interpretation. What the Younger Dryas does not provide is evidence of a lost advanced global civilization. Archaeological sites from this period, whether it be Clovis in North America or the Natufian in the Levant, show complex hunter-gatherer societies, but nothing resembling a technologically advanced empire erased by cataclysm. And yet, when someone encounters an underwater structure that looks geometric, the leap is immediate. Which brings us to the Yonaguni monument off the coast of Japan. Discovered in the 1980s by a diver, Yonaguni consists of large sandstone formations with flat plains and sharp angles, typically telltale signs of human manipulation. Some researchers argue the formations are natural, the result of jointed sandstone fractured along bedding planes and modified by erosion. Others suggest human modification, pointing to what appear to be steps or terraces. The question that matters archaeologically is not whether it looks artificial from certain angles. The question is whether there are associated cultural materials, tools, ceramics, habitation layers, datable organic remains, clear quarry marks, cultural debris. To date, such evidence has not been conclusively demonstrated. This is where methodology separates speculation from inference. Archaeology relies on context. A carved stone without associated material culture is an anomaly. A carved stone embedded in a stratified cultural layer with artifacts and datable materials is evidence. Online, these distinctions blur. The image of Yonaguni circulates without its geological context. The human brain is wired for pattern recognition. Orthogonal angles trigger architectural interpretation. That does not mean the pattern is cultural. But dismissing public curiosity outright is unhelpful. The impulse comes from something valid, the recognition that our understanding of early human history is incomplete at best. But the incompleteness is largely structural. If sea levels rose approximately 120 meters between the last glacial maximum and the mid-Holocene, then vast areas of what were once habitable coastal plains are now submerged continental shelf. Offshore survey is expensive, it's technically demanding and geographically uneven. Much of it remains unexplored. Is it plausible that we are missing settlements? Absolutely. Is it plausible that those settlements belong to advanced technological civilizations exceeding known archaeological development? That requires evidence not currently present. The earliest urban societies with monumental architecture, Uruk in Mesopotamia or Old Kingdom Egypt, for instance, emerge around the 4th millennium BCE. Their material culture is continuous with earlier Neolithic developments. There is no stratigraphic layer suggesting a prior advanced global society whose knowledge was lost and later rediscovered, so far. When archaeologists excavate early Holocene sites, they see incremental change. Domestication of plants and animals in the Fertile Crescent, sedentism increasing gradually, population density rising, disease profiles shifting as seen in skeletal remains with evidence of tuberculosis and other pathogens linked to close living quarters. These are profound transformations. They do not require vanished super-civilizations to explain them. So what is the real mystery? It lies in scale and bias. We are reconstructing the origins of civilization from a dataset that excludes much of the former coastline. Early agriculture may have had coastal components now underwater. Migration routes may trace submerged river valleys. Oral traditions of floods may encode collective memory of post-glacial sea level rise. Consider the Black Sea flood hypothesis. Some researchers have proposed that rising Mediterranean waters catastrophically flooded the Black Sea basin around 7,600 years ago, when rising global sea levels overtopped or breached the Bosporus sill and marine water began pouring into what may have been a lower elevation freshwater lake. Core samples from the Black Sea shelf show a transition from freshwater mollusks to marine species, along with changes in sediment chemistry consistent with salinization. The debate centers on rate. Was it a dramatic cascade of water carving channels and rapidly expanding shorelines, or a slower marine transgression that unfolded over decades or centuries? Ryan and Pittman's original model in the 1990s suggests a sudden, high-volume inflow capable of displacing coastal populations quickly. Subsequent work has argued for a more gradual process, with geomorphological and stratigraphic evidence supporting slower reconnection. Either scenario would have transformed surrounding lowlands, altering fisheries, drowning river valleys, and forcing communities to relocate as the shoreline migrated inland. The archaeological record along the margins remains fragmentary, but the environmental shift itself is not speculative. It is visible in sediment, microfossils, and geochemical signatures preserved beneath the Black Sea. Flood narratives appear in Mesopotamian texts, including the Epic of Gilgamesh, and later in the Hebrew Bible. The presence of flood stories does not confirm a single global deluge. It does suggest that rapid environmental change leaves cultural traces. So when people say the ocean is hiding something, they are not entirely wrong. It is hiding paleo landscapes, seasonal camps, fishing stations, perhaps early sedentary communities, now beyond routine excavation depth. It is hiding evidence of adaptation to climate instability at the end of the Pleistocene. The ocean is not hiding a technological civilization capable of global infrastructure. Or at least, I haven't seen sufficient evidence to sway me to that position. The absence of metallurgy beyond stone, bone, and early copper in relevant stratigraphic layers matters. The absence of anomalous materials matters. Radiocarbon chronologies matter. Dendrochronology, tephrochronology, luminescence dating. These methods cross-check one another. If there were an advanced Ice Age civilization with engineered stone cities on continental shelves, we would expect material signatures. Metallurgical debris, synthetic compounds, structural patterns detectable in high-resolution bathymetric mapping. Instead, what marine archaeology reveals, patiently, methodically, is continuity. Continuity between late Pleistocene foragers and early Holocene farmers. Continuity between inland and coastal adaptations. Continuity between environmental change and human migration. There is drama in that story alone, even without lost empires. Imagine standing on a coastal plain 10,000 years ago and watching the shoreline move inward over generations. The spring your grandparents relied on grows brackish. The fishing grounds shift. You move your settlement slightly uphill, then further. Eventually, you have to leave entirely. Thousands of years later, divers document your house foundation beneath meters of saltwater. Your well stratigraphy records the intrusion of marine shells. Your burial remains in place because sediment sealed it. That is not fantasy. That is marine transgression recorded archaeologically. The seductive version of Atlantis promises revelation, a hidden truth that overturns academic consensus. The actual archaeological record offers something subtler and in some ways more unsettling. Most of early human history unfolded along landscapes we can no longer walk. We are reconstructing our origins from fragments left behind by environmental filters. If that feels incomplete, it is. The question worth asking is not whether there was a forgotten advanced civilization erased by catastrophe. It is how much of ordinary human development lies submerged beyond systematic survey. What might offshore settlement cores reveal about early plant domestication? What submerged river deltas might preserve stratified camps? How might advances in sub-bottom profiling, ROV exploration, and sediment DNA reshape our understanding of coastal prehistory? Marine archaeology is still a young field compared to terrestrial excavation. Technology is evolving rapidly. Autonomous underwater vehicles now map seafloor at high resolution. Multi-beam sonar reveals paleochannels and structural anomalies. Targeted excavation underwater remains expensive, but it is expanding. The ocean is not an archive of lost empires. It is an archive of early human adaptation. And that archive is only partially opened. The persistence of Atlantis in public imagination tells us something about our relationship to history. We sense that something is missing. We see submerged ruins and intuit depth beyond the record. That intuition, that the record is incomplete, is correct. The leap from incomplete record to advanced forgotten civilization is where the evidence thins. If you are skeptical of grand claims, good. If you are skeptical of dismissal without explanation, also good. Archaeology advances by questioning assumptions, not by defending dogma. The end of the last ice age was a period of profound climatic instability. Sea levels rose, ecosystems reorganized, human societies adapted. Some sites drowned, some moved inland. Some vanished from accessible record. There is enough real mystery in that transition to occupy us for decades. The ocean does not conceal an ancient superpower waiting to be vindicated. It conceals the earliest chapters of coastal human life. Chapters written in sediment, isotope ratios, joint wear, charred grain, and drowned foundations. If we are patient enough to read very carefully, the story is expansive, dynamic, and unfinished. And that unfinished quality may be the most honest answer to why Atlantis still echoes across the internet. Not because it happened, but because we know the sea took something. The work now is to determine precisely what. Stay curious, stay current, and thank you so much for watching.